Okay, number 49. This one's a little bit trickier because you have to think about a couple extra things, but it's not too hard. Okay, so in number 49, we have the limit as x goes to 0 of the cube root of x. We try out direct substitution and we find the cube root of 0, which we claim is 0 itself because 0 is equal to 3 zeros multiplied together. So, we need to show that if x is no more than delta away from 0, it will imply that our function is no more than epsilon away from our L value. And our L value this time is 0. So, we can look at our height, and one thing that we do is I say, all right, well, if I want the cube root of x to be less than epsilon, and I assume let's pretend like this is true for a minute, then I would know that if this was true, then if I cube both sides, or if I say that if I cube both sides, yeah, I would know that this is also true. That if I cube epsilon, and I find epsilon times epsilon times epsilon, it should be still greater than the cube of the cube root of x. So down here, I know that these absolute values can be multiplied together inside the same absolute value. So therefore, I would know that my absolute value of x would be less than epsilon cubed. So I could choose a delta equal to epsilon cubed. And that would be provided that the cube root of x was indeed, or the absolute value of the cube root of x was indeed less than epsilon. But we don't actually know that. This was a hint, right? This was us working out what we think that delta value should be. But we need to show that the proof works in this direction, right? We're assuming this to try and prove this, and we're not working in the reverse direction. So we have to show that this direction works. We now have a delta that we can use, but we have to show that delta works. So we need to show that if the absolute value of x is less than our delta value, and our delta value we said was epsilon cubed, then we need to show that our f of x minus L will be less than epsilon itself. And then that means that we need to show that the cube root of x is less than epsilon. So one thing that we can do is take the cube root of both sides of this. And that means that we're taking the cube root of the absolute value of x. Now, we could just switch them around and make them, or instead of taking the cube root of the absolute value, we could just take the absolute value of the cube root. But we might not actually know that these two things are equal to one another. So we could try to work that out in our mind and say, hey, are these two things equal? We could try it out for, let's say, maybe one value first, right? We take the cube root of negative 8, and that's negative 2. If you take the absolute value of negative 2, that equals 2. If we take the cube root of the absolute value of negative 8, That's the cube root of 8. And that's also equal to 2. So at least for negative 8, this works. What about in general? Well, to look at it in general, we could use the definition of an absolute value function. One definition of that was to square the number and then take its square root. Another way of writing that would be to say x squared to a power of 1/2. Now our absolute value is all in terms of powers, right? So let's start at this point and see if we can work our way to something that looks like this. So the cube root of the absolute value of x is the same thing as saying the absolute value of x to a 1/3 power. The absolute value of x is the same thing as saying find the square of x, then take its square root. So we'll replace absolute value of x with this definition that's all in terms of exponents and powers. Taking a power and raising it to another power means that we multiply those powers together. So this is the same thing as saying this. Since multiplication is commutative, we can move this 1/3 term to the front. So we can have x to a 1/3 times 2 times 1/2, all x being raised to all of that. And we can write it with parentheses just as we had decomposed it before. And we get x to a 1/3 squared to a 1/2. But this is the same thing as saying the absolute value of whatever is inside here, right? So if this was some quantity squared and then you take the square root of it, that's the same thing as saying the absolute value of the cube root of x. Tricky if you think about it, but at least it puts it in a little bit of context. So if the absolute value of x is less than epsilon cubed, then that would mean that the absolute value of the cube root of x would have to be less than epsilon. So if you gave me, let's say, that epsilon, the height of our box, was equal to 2, right? Our limit point being 0, 0, our origin. This would be my height, and I would claim that my width would have to be, delta would have to be 2 cubed, or 8. So the width of my box would be 8, or the half width, excuse me, and the half height would be 2. And as I close down, every time that, let's say, you gave me epsilon equal to 0.001, then delta would be 0.001 cubed. And I should get a picture, which is very similar to this one, only instead of negative 2 and 2 and negative 8 and 8, I would have 0.001 above, negative 0.001 below, and whatever the cube of those are on either side. Okay, so that was number 49, and we'll continue on with some others. This is actually one of the trickier ones if you wanted to do it right. So, hopefully I scrolled down so that you could see this part right here, right? Okay. Moving on.